And if you feel like I'm going too fast, that's the beauty of a video. Just pause it, rewind. You can pause it anywhere you need to and continue on. So now example 1. I realized what we just did was technically the first example, but it was part of sort of like what I was illustrating. So I'm just going to call this example 1. You are told to simplify the square root of 27. Anytime you're asked to simplify, one thing should come to mind, and that is it a perfect square? So check for perfect square. And guess what? 27 is not. So now, if it's not a perfect square, you can move on to the second thing, which is then the same question we asked on the previous problem, and that is, okay, so what are the factors then of 27? And don't complicate this, y'all. Just make a table. 27. If you know your multiplication facts, this should be very straightforward. If you don't, then use a calculator and start at 1. Try 27 divided by 1. You would get 1 times 27. 27 divided by 2 wouldn't work. You'd get some decimal. 27 divided by 3 works though, because 3 times 9 is 27, and that's actually what we needed. So I'm going to use this pair of numbers to rewrite this now. So now I'm literally just taking the square root of 27 and I'm just rewriting it. Essentially, I am just figuring out a way to make it look different. Still equals the same thing, technically. I'm just making it look different to make it easier to manipulate. And just to kind of give you a preview of why that's so important. In order to add and subtract, you have to have the same number under the radical. So if you've got 2 square roots that don't have the same number under the radical, you can't actually add and subtract them until they do. So with this, the square root of 27 is the same thing as saying the square root of 3 times 9. Or you could do 9 times 3, it doesn't matter. And I'm not going to keep writing the square root of 27 because you don't actually have to. And I want y'all to get used to seeing like the way you can show work in mathematics. So this is the same thing as the square root of 3 times the square root of 9, which is the same thing as saying the square root of 3 times 3, which is the same thing as saying 3 times square root of 3. Why did I flip that? Because the convention is that we put the radical on the back end. Basically, when you get to your final answer here, you can tell that's 3 square root 3. If you put this 3 behind it, still technically equals the same thing, unless somebody thinks that you're writing 33. I'm going to say that again because I don't want anybody getting confused. We're multiplying square root of 3 times 3, but I want this 3 out in front. Because when I write my final answer, I don't want anybody to think that this 3 is actually like back here under the radical. I want it to be very clear what is outside of the radical and what is inside the radical, especially in the case of this when you've got like a 3 outside and a 3 inside. Don't want to mix those up. And that's actually your solution. And yes, you should be circling or boxing your answers. So now we have something that I think is a little more interesting. And I say that because I would suspect people would approach this different ways, and I'm going to show you some of those ways. So example 2. It's honestly not a very large number, but it's large enough to cause problems. So simplify the square root of 72. And when I say it's not a large number, I mean like we hadn't even gone over 100 people. This is still a number under 100, but it's a good bit more complicated than what we just did, unless you're smart about how you do it. And I'll show you what I mean. So first step, check for perfect square. And that's a hard no. Second step then is find factors. So again, don't complicate this, just make you a list. But with a number like 72, some interesting things happen. So again, use a calculator if you have to, but you have 1 times 72, you have 2 times 36, you have 3 times 24, 4 times 18, 6 times 12, and 8 times 9. Usually we look for perfect squares. I want to be clear here. Technically, you could rewrite the square root of 72 using any of these pairs, but we care about the perfect squares. The only thing about that is we have more than one pair with perfect squares now. So like you've got 2 and 36, you've got 8 and 9 down here, and you've actually got 4 and 18 right in the middle. All of those pairs feature a perfect square. And I'm going to show you now what happens. So basically you've got 3 different options here. Technically, again, you could use even the ones I haven't put a box around, but we're trying to simplify this as quickly as possible. So square root of 72. I'm going to show you 3 different ways that you can get to the answer. Might only be able to fit 2 on this page, but nonetheless. So first one would be using the 2 and the 36. So I can just say the square root of 72 equals the square root of 2 times 36, which is awesome because then I can just say it's the square root of 2 times the square root of 36. I'm getting kind of close there. Sorry. Equals the square root of 2 times the square root of 36 is 6. Square root of 2 times 6 is just 6 root 2. That's your answer. Just that quick. But now look what happens if we use one of these. So I'm going to use 4 and 18 now. Square root of 72 equals square root of 4 times 18. It's going to work still, but you're about to see that it takes more steps. So square root of 72 equals square root of 4 times 18. And for the sake of space, y'all, I'm going to move my equal sign over here, which is okay. Just understand that the square root of 72 is still there. Alright, so now we've got equals, the square root of 4 is 2 times square root of 18. And here's the issue. Over here, whenever we took the square root of our number that we found, we were basically done. Like you found 6, you had root 2, you were done. Here we're not, because you still got square root of 18, which is not simplified. So yeah, you'd have to like actually do the same thing you did over here and find factors of 18. I'll save you that trouble though. Just think of the perfect squares that go into 18. It's 9 times 2. So what you're actually going to do here is say, all right, so this is the same thing as 2 times the square root of 9 times 2, which is the same thing as 2 times the square root of 9 times the square root of 2. And the square root of 9 you can do, that's 3. So it's just 2 times 3 times square root of 2. 2 times 3 is 6. And you get square roots of 2. Now notice, this was the answer I got over here. This is the answer I got here. These are the same. This was a whole lot less work. So if you want to see this other one worked out, the 8 and the 9, you can look at the actual notes that I put up from the video. But the takeaway is this. You can always simplify a radical by breaking the radical into smaller factors. However, the shortest and most efficient path is by using the factor that's also the largest perfect square. In other words, when I'm looking through this list of numbers, I want to find perfect squares, but I want to find the biggest one possible. So here, 36 is a perfect square. By using this pair right here, all I had to do was find the square root of 36. I got 6. 2 is what was left under the radical. I was already at my answer, basically. Like me understanding this process, I could have looked at this table and just did it in my head. And all of you can get to that point too once you understand the process. In the meantime, don't create extra work for yourself. Make a table of values and find the largest perfect square and use that. And now for 3 problems for you to try that I will talk about in class. You try. And they will be 1, and again, we're simplifying all these. But the first will be the square root of 18. The second will be the square root of 50. And the third will be the square root of 98.